Welcome to the Anti-Pattern Podcast, your ticket to the revolution in digital thread technologies. Please welcome, live from Mannheim, Germany, your hosts, Christian Muccio and Michael Fenning.
Hello everybody again to the Anti-Pattern Podcast, to the next episode here from downtown Mannheim, right behind the train station again. We are not moving anywhere else, so we are still in Mannheim and Imaffinex Startup Center. Together with me again, Christian, I'm Michael. And today we are kind of improvising, so there is no cheat sheet that we are looking at. Sometimes I make a picture of the cheat sheet and load it up into Instagram so that people can follow what we are writing down and what then actually comes out of our mouth, which is not always the same.
Might differ.
But today we are a little bit more improvising, so nothing to read out from, because we want to take a special or focus on a special topic today, model-based systems engineering. And Christian has been to the Systems Engineering Congress, organized by the Center for Systems Engineering from Aachen. And so what's new?
It was pretty interesting. So to my surprise, there were plenty of presentations from different industry that really gives me the hope that MBSE finally settles also in Germany.
Okay. So in outside Germany, it's already settled, or is it still also ongoing? Or what would you think?
I think it depends a little bit on the countries and on the regions. So definitely in the United States, systems engineering is much more common than it's in Germany. So you don't only have to look in courses at the university. You can study systems engineering in various locations in the United States.
True.
In Germany, there are
lectures about it.
Lectures and 2, 3, 4 studies or universities who claim to teach systems engineering.
True. Yeah, so the one thing is the academical world, so to say, right? And Germany does not. I actually do not know of a study course called systems engineering. I know of lectures for engineers called systems engineering, system analytics, something like that, right? But on the other hand, in the practical world, in the real world, in enterprises, what is your feeling there? How far did we come with the introduction of modeling by itself, systems modeling?
Yeah.
What is your take on that?
It's the same story as it was over the last decade in MBSE. So companies already do systems engineering without knowing systems engineering to a certain extent.
Right.
And more companies, especially now in Germany, what we've seen on the Systems Engineering Congress, really are aware of systems engineering and model-based systems engineering, and especially with SysML v2, there comes a language which gets much interest.
Yeah, and I remember the two of us, we met at university, but basically back in those days, right, we were both visiting the object management group for the first time, right? And I still remember that I've been part of, and you later on as well, part of the SysML roadmap group. Working group.
Right.
Yeah. So this was before anyone was talking about SysML v2, right?
It's 11 years ago that this group was founded.
Yeah, I remember. It's
and
long
now
ago.
In July, finally, the 2.0 language was released.
Yeah, true.
So it took 11 years.
11 years from there to there. Yeah. So that tells us how long standardization can usually take, right? Or sometimes take. But comparing those two and contrasting those two, SysML v1, right? And there were some drawbacks, or there was some flaws in the language,
right?
That we are aware of. What actually changed now with SysML v2 in your view?
It's a topic for various episodes. So
good to know.
They didn't leave one stone on another, so to say.
Okay.
And that starts with a whole new meta model. So SysML v2 is not dependent on UML anymore.
Right.
But therefore, there is now another meta model called kernel, the kernel modeling language, which might be possibly in future also the mother language or the meta model for UML3, for example.
I see. Yeah, this was usually one of the criticisms that a lot of people had. And once I understood it, I also had that criticism. And that is that it's actually the wrong way around, that the UML is the basis for SysML, right? Was, yeah, because it usually should be the other way around, because you first describe a system and then what's left for software can then be described in something like UML, because UML is the modeling language for software systems, right?
Yeah.
So it was always the other way around, as you usually would expect.
Exactly.
So that is fixed. Good.
That one is fixed. And on this new foundation and this whole new class of modeling languages, so to say, and SysML v1 is the first one.
Yep.
They fixed a lot. So we can only name examples now. And one is, of course, they fixed much in the sense of the distinction of structure and behavior. For example, the whole behavior part is totally different, and all the 4D ontologies allow you now also to take time in consideration.
Yeah, I remember the time, which for me was always kind of a detail, but an important detail. What you are saying is back then in V1, we had that situation that structural side and behavioral side, they were kind of two silos separated. Right.
And only a sequence diagram somehow took time in consideration, but it was also not really standardized, and
I see.
Gave you a lot of headaches.
The better integration between the structure and the behavioral silos, right? In V2, we now have that. And what I learned from you is the textual representation.
Oh yeah, the textual representation might be, or from my point of view, is even the bigger deal.
Okay.
Because now that we have a standardized textual representation, we have definitely one possible format for model exchange.
Okay.
Of course, it lacks a little bit from of IDs, and if you get two versions of the same model, you have to take assumptions if it's really the same part or part def or whatever model element.
Right.
So that's a little bit the downside of the language. The other one is you can version it with Git perfectly. It's just text. You have a full version control in a Git repository. You can email it. It's great.
Yeah,
it's really cool.
And some people will prefer textual, working in a textual way with the system.
Yeah,
over a graphical.
Right. And this is also cool that all tool implementations, which I'm aware of, it do support this duality of graphical notation and textual notation.
Great. So that one also gets a check mark, right? Textual presentation was something missing, right? Okay, I see. Except maybe for XMI, but that's not really comparable, right? XMI
yeah, that's
basically
not
just the
exactly
exchange format. The other thing that I was wondering, what else is missing, or let's say a higher usage of model-based systems engineering in the real world, except for things in the language? Yeah. What else would you see as a challenge to introduce MBSE currently?
It depends a little bit on which or what kind of MBSE models you're referring to, but at least in the field of systems architecture and behavior with SysML or SysML v2, we now close a gap, which is the biggest change from my point of view, that we now have an API.
Okay. Yeah.
Because the API now, a standardized API, that's very important. Because with a standardized API, all this information in the models, all the single modeling artifacts can be linked and used in downstream processes. That was not really possible before. So maybe you had a one-to-one integration from one tool to another tool for millions of dollars or hundreds of thousands of dollars.
Yep.
And these times are over now.
Yeah, lucky. That's actually great that those times are over with the standardized API. So agree. The other thing, it connects, or it goes in the same direction. My feeling was always the steep learning curve of modeling itself, right? Together with the fact that most of the modeling tools are not really connected or not really heavily used in the real business process was challenging or is challenging. What do I mean with that? Those tools, most of the modelers were desktop applications, right?
Yeah.
They were used on a laptop. And the information that, people created, systems engineers basically created, were never downstream reused because there was no way to do it, right? Then people started, even with V1, to introduce some, we call them TDM systems, right? Team data management. From our friends at NoMagic, that was the Teamwork Server, Teamwork Cloud, right? Those kind of systems. But they were only meant to manage system model data, right?
Yeah, from this one tool.
From this one tool, usually in a proprietary way, right? So that was a problem. And the real benefit or the real technical prerequisite to actually make it more usable in an enterprise IT setting would be to actually use the system model as the meta model for all engineering models, right?
Yeah, and that would be the dream for many of the practitioners.
Yeah, me as well. So this would be the glue in the end that then holds everything together, right? Would you say we are close to achieving this, or is it still a long way to go?
No, I'm thinking that we are very close to this. So we already see in the pilot implementation, and we will see in several tools in the next months, that we now have this central repository connected via the standardized API. And this alone shows me that, for example, we could take over this information in our knowledge graph.
Right.
And from there, we could deliver or spread the information into other server-based tools, or even into an authoring tool.
That would be the great question. Or the next really interesting thing that we should discuss is what role do we play in this, right? We, with our digital platform, right? We basically are able to set up a knowledge graph for any kind of usage, right? Whatever it will be. If I look back into last years, I have been, for my dissertation and later on when I was working for PLM vendors, we had a Cameo connector, right? Cameo Systems Modeler connector for a PLM system. This is usually always the weakest way to go, that you have some authoring system modeling authoring system, and then you have a connector that then brings some of the information together with a big file, a container of information, into a PLM system, right? That is, the way you would do it 10, 15 years ago. Today, with our platform, we are able to bring things closer together in a more fine granular way, right?
Right.
So how do we do this then? What's the difference between having a modeler connected to a PLM system? On the other hand, what we are doing is having everything fine granularly integrated, right? How would you describe that, what you're doing there?
It again depends a little bit on the use case, but in the end, what you did with these one-to-one integrations in former times was that you grabbed into the model normally, and you pulled out blocks of certain stereotypes, for example.
Right.
So just the information that you know that with your method will exist in this model, and which you need in your PLM context, so to say.
Right.
And the problem with that is that you always lose some details, which is not by accident, but but you never know for what you need these. You will need this information later on.
Right.
So you lose some granularity, and you lose some details, and it works for now, but you don't know if it works for later.
Some would say I can solve that problem if I'm doing a really great job at deciding how granular I want to have it, how detailed I want to have it, and then if I implement it in that certain way, then that problem is not there. It's just a matter of the method, so to say, right? That's what some people would say. The other argument for why not use just in connector to a system model is the lose of, or the drawback of having to synchronize data, which means some system engineer would be working on his laptop on a system model for weeks without committing, without sending back some additional updates to the central component, right, which is the PLM system. If you don't have that, if you have everything on the server side, basically, because our modeler will be, so we have a basic modeler already in there. It's not SysML compliant at all, right? But maybe we are going that direction in the future, right? But our model is completely on the server side, which means there is no delay between someone changing the model and others are being able at least to view it, right? So this timely separation, right? That issue is not there anymore if you do it completely on the server, fine granularly integrated, right?
Yeah, in these cases, if you have a web-based tool, that's true.
Right. So that's the thing that we could help with in MBSE, right? If we choose in the future to go that direction and say, okay, we have our own modeler in there, right?
And even if it's not our modeler, we could also connect to such a repository and get the updates instantly.
Yeah, if such a repository exists, for sure. Yeah,
exactly.
And if it has a standardized API, it's even easier.
Yeah. And the one thing that is really cool on the API is that the API was also inspired a little bit by Git, I would say. So the API is aware of commits and change sets.
Good.
So it really fits good. Also, really fits well with our API.
Right.
Which means we can even take over such information, but also enhance it.
Agree.
For example, what the MBSE community, no, that's wrong. The MBSE community is aware of it. But what the SysML community always lacked from in all the tools was the lifecycle on these models. So what part of the model am I working on? What part of the model might be released? What is in review?
Right.
These are things that we can add in the digital thread, so to say.
Right.
To really make sure that maybe we have a newer version in the graph,
right?
But the downstream processes can only work with the released states because, maybe it's only just trying out something new.
Right. And that was one of the criticisms that many people had coming from, let's say, industries that know mass manufacturing, right? Because there is no way to use something in an enterprise setting if you're a mass producer of something without lifecycle management. Right? No way. If you're building just one satellite a year, right, different story, then maybe you don't need a structured lifecycle management. Yeah, let's see. Maybe not true for CAD systems so much, right? But it maybe is true for system models. But if you have a mass producer of something, right, then there is no way to introduce it if you don't have lifecycle management included. So and this is something we also bring to the table, right? We have that versioning capabilities. We have lifecycle maps where you are able to see, okay, what kind of structure, what kind of data set has what status, right? And you don't have that problem that you need to release the whole model at once, right? This is the way that most of the connectors that I knew of, right, or know of, were working. You had that container of information, and you said, if we want to release everything, it's basically the document, right, where nobody can look into
document, or maybe on package level, but and that was already high sophisticated.
And just to be fair, what we did back then was the whole thing is released. This is the version of the whole thing, of the document. And then we said, okay, we have some configuration items in there. These are things that we want to expose to a lifecycle management system. And this was usually RFLP-T. Don't forget about the T, right? The right side of the V. And that stuff is then, synchronized with, a data model or using another data scheme that is basically part of the lifecycle management.
But with such integrations, you are tied very much to one certain process. And for a different process or for a different use case, you might need to change the connector which is again costly.
Yeah.
And therefore, having this API and having a repository and having things in a knowledge graph, even without the knowledge graph, you can do things you couldn't do before in a beauty that you hadn't before.
Yeah.
So I really like the idea of Yosas from Seaside, from SenseMetry. The Seaside is the tool. They are speaking of system as code, and they are using the idea of CI/CD pipelines working on
makes sense
on this textual notation in this case, and with a duality that we have, that we exactly know this textual notation represents this model.
Right.
You can also bring the results of the CI pipeline again back in the knowledge graph.
Right.
And this is a level of detail and level of traceability you never had before. And it would be very costly to implement something like that without the standardized API.
Agree.
And without the textual notation.
Agree. And one thing to add in terms of what we can bring to the table, what I always found fascinating was the idea that every engineer works with something like a system model. Could be, right, depending a little bit on the company, but in general, that's a really bold statement. If can you really convince a mechanical engineer to use SysML? Maybe some of them, not all of them, definitely, right? So my point is this: having a SysML model or a system model of any kind in a server-based tool, and then having the possibility not just to visualize it in text, not just to visualize it in a graph view, not just visualize it in diagrams that you're usually used to, right? But also having the ability to visualize that in tables, in any kind of masks or forms, right? In any kind of visualization, to actually make other engineers work on the system model without noticing.
Yeah.
They contribute to it without knowing they actually help the modeler in the background.
Yeah.
Right. That would be something that helps to introduce that.
That's absolutely my dream of systems engineering in the future. So just by constructing something in CID, bringing it into the knowledge graph and releasing it triggers, for example, the creation of a realized by or satisfy relationship in the system model without a mechanical engineer knowing it.
Yeah, exactly.
And so you get a real wholesome view of or a whole graph of everything.
Right. I do agree. So something we're working on. To be fair, it's not the first use case that we're thinking of, right? We have other use cases to tackle first, but MBSE is definitely one of them that we see part of, being part of our field, right?
Yeah, especially because MBSE is not one silo; it's very often many silos.
True.
Depending on what you define, how you define it, you have a system architecture silo, you have a simulation silo, you have a requirement silo.
Right. True. So, and then my final question to you, and then I guess we can call it an episode. You're familiar with Fusion. What do you mean with Fusion? In this case, I actually mean the physical,
not the tool.
Fusion to produce energy.
Yeah.
Or people will kill me if I say produce energy. But anyway, so energy cannot be produced; it can just be transformed. Anyway, so in Fusion, the Fusion technology, right, to recreate the process of a star on Earth, right? When people are asked, how long does it take to introduce, or how long do you think do we have to wait till it's achieved, the actual fusion process in a stellarator or something like this? And then the answer is always
40 years.
It's always 30 years, no matter when you ask a question. If you ask it in the 80s or if you ask it today, the answer will always be 30 years. So in that regard, or for that background, how long do you think will the introduction of MBSE on a grade or in a very big level in enterprises in the industry take?
Good question. Yeah. So if you would have asked me 10 years ago, I would have said around 10 years.
This is what I mean.
Maybe 10 years. Yeah. Okay. It's some kind of the same problem, but maybe I would reduce it to 8 now, after seeing all the presentations on the Systems Engineering Congress, seeing the advancements in COSI. And I'm very curious on the TDSE, so what was it? The National Symposium of Systems Engineering in the German-speaking countries.
Yeah, without Switzerland, because they have their own. But
yes.
Yeah, true. Yeah, so thank you very much for your insights.
You're welcome.
Christian is also hosting the MBSE podcast together with Tim Vikins.
Right.
This is why I asked him so much about MBSE, right? If you like what you heard, subscribe to our channel, leave us a comment, a like, and with that being said, thank you very much for listening in. Talk to you the next time.
Bye-bye.
Yep, take care. Bye-bye.